Hello, everybody. So today we will try to do an original talk because I will ask you to be actor of this talk. Do you agree? Yeah. Again, do you agree?
Yes.
Okay, cool. So I will try to do something fun because I think in terms of learning, usually you learn more in this way, but also to give you some information because we are not just here in a game room. I really want to give you some stuff new for you about MBSE. I'm Etienne Juliot. I'm one of the founder of OBO company. We do plenty of modding stuff, but also modding for model-based system engineering. And I am also part of the board of directors of the Eclipse Foundation. Before going in the interactions, let's just explain you in a nutshell what is system engineering. The goal of system engineering is to help you to define complex systems, which means that if you go too deeply and directly to fine-grained design of software or electronics and other, it will be very hard to keep the big picture of the systems. So it's a very big trend in all the industry to be able to inject new innovations in the systems. The main goal of this is to define not the detailed design, not the 3D design, but to focus on the system architectures, how your system is decomposed, and also some trade-off at the architecture designed which mix hardware, software, safety, performance concerns. And what I will speak about is two stuff. A method, Arcadia, and a tool, an open source tool inside Eclipse called Capella. Okay? Okay?
Yes.
Cool. So, how do you do this currently? How we do system engineering in our daily life? To do this, we'll use for all this demo a sample, which is imagine that it is an autonomous driving system, and I want to add a new feature, which is a rain detections. So you imagine that there is a rain on this, and automatically the car will go slowly. Okay, and we will design this feature together. How usually most of engineers work when they define the specification of the system? What is the tool which is a leader on the market? No, not doors. Good idea. Yeah, just after. Sorry? Yeah, for specification in general. Because you say requirement, it's just for company which already have requirement in place. It's not the case of all the company. Yeah, you got it. Office. So let's do with Office. So, it starts to bug. Okay, so I have my specification of my autonomous driving systems. Imagine there are several hundred or thousand of pages which explain all the parts of the systems. And now imagine that you are doing the electronics, you hear the software, and you do the 3D design of cable. Okay? So now, imagine the guy from electronics decide, because of their reasons, to change just one line in the specification to say that the bus will be now IP-based and no more a CAN bus. So that's a kind of a change of protocol. With road, even with requirement, detect the impact to the other teams, it's just a nightmare because you as software guys, you will have to change your API. You don't use anymore the API. And also the latency could change because all the protocols have their own specific stuff. If you change the latency, it could have impact for electronics also. And at the same time, for the 3D design, you have to change for the port, which should be now an Ethernet port. Also, if it's an Ethernet port, perhaps it's too costly, so you have to do an impact to the software. Okay, so you understand, it starts to be very, very complex. So the goal of model-based system engineering is to get rid of office and textual requirements. Let's see what I want. Start by a video which explains the principle. So you have plenty of domain. It works not only in the automotive but in any domain. And the end user wants, for example, in this use case, a more connected car. So he asks for plenty of stuff like being safer, more intelligent, more affordable. You decompose your car in plenty of subsystems. You give each subsystem to each kind of engineering. And like a charm, they work together, the design, and at the end, it's work directly very fine. Is it a real life? No, it's not. So, the reality today is that you give them a bunch of documents, like I show you. All of them are very complex to master, and when you want to integrate, you have plenty of integration issues. So the goal of system engineering is to prevent the integration issue. We have already some feedback of customers who say that they reduce by a factor from 2 to 3 the number of integration issues with system architectures. It's huge. And so that's why Capella has been done. At the end, it doesn't generate code, but it's helped to improve the communications, to do trade-off based on real structured data, to identify problems, and also to do building blocks to reuse some design from project to project. And at the end, it will work. Okay. Let's work now. So, Arcadia. Arcadia is the name of the method which targets the analysis of the problems. So, do you like to do meetings with brainstorming with customers which explains their needs and you do minutes? Who likes this? You? It could be convenient, but sometimes, you know, it's like a circle. You don't really build something together. So the goal of this is each time you do a kind of captures of needs, you go ahead and you go straight away in a better and better specifications. You do architecture binding, also requirement engineering. I would like to just zoom on these ones. We don't do textual requirements with doors or Polarion and other tools and model elements after this. We do model requirements, which means that this system engineering is a part of the requirement itself. Compared to the textual, they are just more structured. So usually you do in the same times requirements and textual requirement and model requirement. You can do in the second step when some customer give you just a textual requirement, you just have to drag and drop to associate them. Here is the datasheet of Arcadia, but to explain this, I will need some volunteer to work with me. So, a volunteer, you. Come on. So you will be the weather. Okay? So you will have to be on the right place here, come in here. And you will have this stuff with you. I need a second person. You. No, you. Come on. Yeah, come on. And you will be the driver. Okay? And you will be on the right place. Okay. So I have two actors. What I am doing currently is what we call the operational analysis. I explained the human interactions, the workflow between external systems which already exist. I don't design the system itself. Very important. I just design the interactions. Here is the existing car. I will not design all my cars. They already exist. The car has an activities which is useful for me. Okay, provide what? provide vehicle status. You will be the driver. You will have an activities which is called
Observe status.
Observe status. And you, it will be harder for you. You have to find what it could be. So you are the weather. What can you do?
Rain.
Yeah, rain. So write rain on this. Okay, and in the same times, I will show you how is it in the tool. Okay. So now, as you can see in the tool, you have the methodology that I explained to you is directly inside the tool to guide the user, which is clearly a game changer compared to something else, to other tools. So I create the weather, I create you there in the tool. I create an activity, an operational activity inside the tool. And then what I will do, I will connect with an interaction, the rain, to the provide vehicle. Up, pause. Just rain warning. Okay. I need something else to help me for all the edges there. No, on the left, the right part. Come on. Yeah, come on. So you will be the assistant. Yeah, each time there is an exchange between actors, you will have to give them one line. So you have one line to do from the rain activities to the provide vehicle status. Okay.
To what? From the rain? I know the rain, okay.
Yeah, there is a hole inside the boxes.
Okay. So
Okay, yeah.
And
I go there. And now, so it's already helps you, good luck, to create a kind of, It's live test. Huh? I never did this talk before. So, and there is a message between the both. So we'll use this each time, okay, to explain that this message go on. Okay. Cool. So you will have other stuff to do. So take another one. So now, take another one. Between provide vehicle status to observe status, we'll say that there will be an information called suggested speed. So go on the other hole, go to the other one, suggested. And now you work and I continue to speak. Okay. So now you can test the rain to see if it works, and you will have a simulator. No, you have nothing. So in the tools here, for example, I also show something I will not show you in live because I didn't find the good idea to illustrate it. It's a process to show a specific scenario, avoid collisions, which use several activities, and in the tool it's highlight all the exchange use, all the activity inside this scenario, which is quite cool to use. Okay. In the tool, you have plenty of other diagrams for the behavior, the dynamics. I just focus on one stuff to be simple, okay? Now, I will design the system as a black box. So I will start to speak about my rain systems there. A black box. I have a black box. So please help me. We'll put the car on the top of the black box. Yep. It's blue, as you can see. Yeah, blue too. So in the tool, we have some nice feature to help user to do a transition from one layer to another one without the need to rewrite again the stuff. So I can do this with a Hollywood effect, which is a transition. You see the noise? It's very cool. And automatically, so Capella generate. Sorry?
The noise is a new feature.
Yeah. No, it could be. And now I will say that this is what I call a function, okay? What the wizard should perform. and you will put the function inside
Okay.
this component. This is okay. What else? Provide status. Can you? Okay, we'll put it on the front. You can scotch it on the bottom. On the bottom, please. And you no, you have nothing to do. You. We'll remove it. I hope to. So you can connect. Here is a new functions we'll have to do, which is adapt the speed. There. Okay. And now I say I forgot something, which is your. What is it? Yep. The stairway and with our back system. Okay.
Oh wow.
So give it. Okay. Imagine now. Oh, the video is going right. Okay. Okay. You see, you can, for example, say, okay, here I put the weather. I see all the functions already allocate to the weather. You see the link as you already made. And now I will create a new actor because to design my system, I need something which is a rain sensor. Okay? So I will take a new one. This one. Where is the pen? Okay. Who should I ask for? Or perhaps you can continue to do this. So you have to write. Yeah.
And I connect this.
Yeah.
Not to that.
I think you can move this one because we are no more in the operational analysis.
Okay.
Yeah. Okay. And
Can I write down at this side?
sorry. Yeah. So you write rain sensor. That's the name of a new component that we will design. Okay. This new component will have one functions, which is to rain sensor detect rain. Yeah, detect rain. So write detect rain and put it, scotch it. Yeah. Okay, and then use your line somewhere to connect this to another one, which is, where is it? Adapt speed to weather condition. Is it already on this?
Also, we need to get the train from here.
So adapt speed, yeah. So you need a connections, which mean that, okay. Oh, it doesn't work. Okay, you need to, this system, detect rain, and so yeah, they will have a flow of data between the detection of the rain to the adapt speed to rain. So which means that you cannot perform these functions if you don't have this function somewhere. And what I'm doing is by using an external blue box here to say that it's not inside my black box. It's not inside my responsibility. Okay, it's something outside. So imagine you connect there, perfect. Okay, and so I did this. So I can ask to the global architect, what are the protocol between these two components? How can I interact with them? And you can decide with the customer who is really responsible of this. In this scenario, let's say I am the product owner, and I say, no, guys, the detection of the rain is part of your responsibility. You will be paid for this, but you have to take care by yourself. It's not part of my responsibility as a car constructors. Do it yourself. So I remove it, and now it is inside my my responsibility, so it's inside these boxes. You got it? Yeah? Not? Yeah? Okay. Let's see how is it in the tool. So I move the connection to say that it's not just directed to the rain. Of course, I need to go first for the rain sensor. I connect other function. Oh, we forgot this one, humidity. So take one. As you can see, the name I use here for the data exchange are named in English. So we are not designing an API. We are not designing the something technical. We are doing the spec, and we want to explain people what kind of data flow you are using. So it's not under my responsibility. So I just drag and drops in my boxes, and I remove rain sensor. So first of all, it's help to define the scope, to define and precisely your scope. Secondly, what do I need to provide a good speed? Do you know? Somebody? Come on, it's right, written. GPS. It was too easy. Yeah, it was simple. The pen?
The pen is here.
Okay. Let's write GPS there. Okay. You are a GPS guy now. Okay. And the GPS, let's go faster, as can provide two stuff. Provide the country, because it's depend of the country, the maximum speed, of course, and provide the maximum speed there. So here we go. Okay. And now you will have two connections. So we'll give it to you. Here it is. Here it is. Okay. To adapt speed to weather conditions. Why did I do this again? Because you see, it's perhaps the same example than before. It's not, because this time I can say that between GPS and my boxes, I need somewhere component exchange. What's a component exchange? Component exchange means that in a functional aspect, you need to have a dependency. So somewhere, you need to have a concrete link between the two systems. Later, it could be a cable, an API call, you don't care, but at least you need a link. It helps you to define the integration point in the early stage. Okay, so this will be called the regulations, and it will support this functional exchange. So you have a full traceability from the functional analysis to the logical design, which is very, very cool. How you do this? You will do like a Jedi. Okay. You have to open it with the red button. Good luck. Yeah, go. No, put like this. Again. Yeah. Okay. And you go to the boxes like this. And put regulation on the other side so people can see. You get it? Okay. That's funny. So in the tool, you can hide some elements. In the day, there are plenty of functional like this. You can have sequence diagram too. I will not ask you to do sequence diagram in live. Okay. So now I finish the system analysis view. Okay. And I will go in the logical architecture. What's the logical architectures? It's when I open the box. So I will work this time as a white box system and will design the subsystem of my project. Okay? So inside this box, I have the image processing stuff. Do we care for the rain detections? No. Okay. We have the turning assistant for autonomous driving. Don't care. Okay. And we have the regulation adapter. Yeah. Oof. Okay, so it is a part now of my system. What's the scenario? Oh. To do this, it will be this one, which will, so you, as well as the actors, the driver, we will say that at the logical design, you have several options to show an informations. You can use the dashboard, or you can use your own glasses for direct. Sorry? Yeah, a Google Glass, exactly, doing your rain. And you will have to choose where you want to display the speed advice. So that kind of stuff also a trade-off you can do at this level. On the design, the internal design also of my systems, I create my regulation adapter. I already find it. And inside this, I have new functions, which was not inside the black box the previous level because it's internal functions to perform what the user expects from my systems. So that's my internal choice. So I can create, where is the last one? The display speed advice. Okay, so you get the ID. I reconnect. I think I will not do this. You already understand the principle, okay? Last, okay. Oh, just this, the last one will be the physical one. Where is it? Okay, physical one. It's to do some choice in terms of hardware or in terms of physical system. Should I need for my sensor to use a physical one, like this one? Okay. Should I need to use a specific CPU, an Intel, or should I let the choice of the CPU to my supplier or the downstream teams? That's the kind of stuff you do. You can also put some constraint, some architecture constraint. For example, you want to say that the cost of these adapters is this one. That you have some timing system, some performance constraints to say that it should break in 2 seconds, for example. And also, you need to have some safety concern. So to be sure that you have the good level of safety, if you have some consequence, some problems, how you deal with this. Do you imagine which kind of safety system I use to illustrate this? What is the safety system we save the more people in the world? Okay. Okay, thank you, guys. You can keep it. No? So, I put this like this because I didn't see you. Okay. Oh, it's my cache. Yeah. So the main objective of this is to better understand the needs, define solutions with stakeholder. So that's kind of interaction we are doing. We are doing this like a game, but in reality, people use Capella in a meeting room, and in live, they are doing this kind of choice. It's help you to prepare subcontracting because so your statement of work is really more precise. To evaluate and justify also architecture choice, and to prepare the verification validation. Wow! Compared to SysML, it's inspired by SysML. It's it's come from decade of experience about UML, CSML, and language like this, but it's really simpler and it's go beyond CSML. For example, if you want just to do what we made for the system design in CSML, you have to use 5 different diagrams because you have to do the breakdown diagrams, you have to do internal block diagrams, and so on and so on. So the principle is to, which drives the design of Capella, is to design some engineering activities and to do diagrams environment focus on this to make it simpler. And it's really for CSML v2 in the term that lots of stuff inside Capella are in the same spirit than CSML v2. So the workbench proposed methodological guidance, plenty of power tools. It's very, very mature for design. For example, when you design details, dependencies between your components, the tool automatically compute the high-level dependency. So you don't have to maintain them by hand. You have the principle of color map. So it's very convenient to each time you see something green, it's about function. Oh, come. Wow. Okay. Sorry. You have validation. So you can use all the modeling technology which are presented at EclipseCon. You can have a contextual browser to see the dependency of one element to any other in other layer on other to do impact analysis. You can do building blocks, so reusable part of your models. So you create library and you just assemble library together to speed up the design of your systems. Very, very important, this one. And you can also do model to system to subsystem transitions. So you have one general teams which design, for example, the car, and some other team which just design the rain regulation systems, and so perhaps another team which do just the sensor. And all this different granularity is managed by the tool. You can add some specific trade-off depending on your business. So it's very, very extendable. And last, if you want to work together, you have 2 commercial add-ons on the top of Capella. One which is for live collaborations provided by OBO called Team for Capella. You know Google Docs? So basically it's very similar. The model is stored in a database and you have some lock system at a fine-grained element. So as soon as somebody modify an element somewhere, it's locked just this element and the other user we cannot modify it in live. So you can continue to work outside of this element. And so it's very, very fluent and easy, and it helps to scale. The second kind of collaboration is about the digital thread. It means that you want to connect this system architecture activity to other tools and other activities. So it's made in partnership with Siemens. I think you were at the keynote of Siemens when they explained this. And it's really is a game changer in the industry because it removes silos between teams. And so, for example, you are inside Capella, you just push to the PLM, which is Team Center in this case. You have the model inside the web browser. You can have traceability to electronics, 3D design, simulations. You know, every time each part has been translated to what in the downstream engineering. And you can, for the integration with requirement, just have the web here, web part. You drag and drop a requirement to an element, and you have the traceability. So very, very cool. So it's called System Modeling Workbench, the name of the product. Yeah. Okay. Who is using Capella? Plenty of customers. We couldn't already, which try to track who is using it. It's quite complex with the open source, but we already detect 200 different companies which are using Capella. So some of them already made some success story. Thales, Ariane already, Continental Automotive, Areva for the plant systems, Rolls-Royce in the aeronautics, so and other. We made, and it will be my conclusion, an analysis from 300 projects to know what was their feedback about Capella in the real world. And they give us this feedback to explain that a large part of the user is using Capella not to create new system, but also to make just an evolution on an existing systems, which means that what we do there was a top-down approach, but it's used commonly for also existing system where you start from the physical system, you describe what you see physically, and you go to the logical there. And the main benefits and concerns that people see are here. That's quite similar to what I announced at the beginning. Hopefully, what we promised was the reality. There was one point which was quite interesting. I think it was also the management of product line and variability when you have plenty of different products. So I hope you enjoy this way of doing this presentation. I hope it was different, but I hope also that you learn something during these presentations. Feel free to download Capella. Yeah, there are plenty of webinars on the web, plenty of video tutorials. So I hope that you will like it. Thank you. Some question?